So today we are going to discuss about chemical kinetics. So chemical kinetics it explains what chemical means chemical reaction. So chemical reaction kinetics means speed or velocity. So what the chemical kinetics explains the chemical reaction, so how it is proceeds with velocity. So that is explained by the chemical kinetics. So chemical reactions. So how the chemical reactions are takes place generally, some chemical reactions are fastly takes place. Some chemical reactions are slowly takes place. Some chemical reactions are moderate or medium speed. So the chemical kinetics does not explain for fast reactions. It does not explain for slow reactions. So for moderate reactions only, it is readily explaining. Next, this is what with respect to time. Speed or velocity means with respect to time. So that's why the main important point here rate. So rate means 1 by time. So whatever the process happened within particular time, you called as a rate. So here reaction. What is the meaning of reaction? See, atom is combining with atom. You are getting a molecule. So molecule 1 react with molecule 2. You are getting molecule 3 plus molecule 4. So this left hand side of this one equation, so is called as reactants. So the right side molecules you called as products. So what is happening in the reactants? So here bonds are breaking. In the reactant side, bonds are breaking. In products side, new bonds are making. So in a chemical reaction, what happens? The reactant concentration is decreases and the product concentration is increases. So with respect to time. So with respect to time, what happens? Reactant concentration. Reactant concentration is decreases and products concentration. So the product concentration is increases. So suppose you are taken in the graphical manner. So you take x-axis, y-axis. So on y-axis you take a concentration. On x-axis you take a time. So time increases. So first of all, what happens in a chemical reaction? Reactants are we are taking. So more concentration. With respect to time, the reactant concentration is gradually decreases. This is reactants. So starting product is 0. So with respect to time increases means the product concentration is increases. See, in what way it is increases? It is not linear, it is exponential. So the increasing or decreasing in the exponential manner. So because of what? Bond breaking, bond breaking and making. So this is depending upon the energy values. So that's why that decreasing of reactants or increasing of products must be exponential manner. Reaction rate. Reaction rate. Also it is called as a rate of reaction. So both are same only. So here the reaction rate, that means the amount of reactant is decreases. So reaction rate equal to amount of reactant. Amount of reactant decreases divided by time taken. Otherwise, so amount of product concentration increases divided by time taken. So the reaction rate is indicated with, it is dx by dt or dc by dt or dA by dt. So different books they will provide in different manner. Next, the reaction rate decreases. Decreases amount is indicated with a negative sign. So amount of reactant is decreases. Decreases means we write negative sign. So increases. Who is increases? The product is increases. So that is we are taken with a positive sign. So the signs, whatever the given sign, it is not mathematical value. So minus means it is decreasing. Positive means it is increasing. That much only you must important here. Reaction rate units. See, it is reaction rate is what? Dx by dt. Dx by dt means x is nothing but concentration. Concentration by time. So what is the unit of concentration? Mole per liter. Moles per liter per time. So otherwise mole per liter per second inverse. So otherwise instead of time, second inverse, minute inverse, hour inverse, otherwise year inverse, whatever it may be, you can write. So moles per liter per second. So this is one important units. Next, the reaction rate, how it is. So we are classified into two types. That one is average reaction rate. Next, instantaneous reaction rate. So this is delta x by delta t. So bigger value something. So it is dx by dt, smallest value. Suppose you take a graph. So x, y. So on y-axis you are taken concentration. X-axis we are taken as a time. So reactant concentration is decreases. So at a two particular points values. See this concentration, you take R1. this time T1. So here the concentration is R2, the time is T2. So now that average, so average reaction rate equal to, so that is indicated with delta X by delta T. That is nothing but concentration. So concentration is R1 minus R2 divided by T2 minus T1. So in the problems also they will ask, they will provide two concentration, two time values, and they will ask what is the average reaction rate. So instantaneous means the same. So x-axis you take a time, so y-axis you take a concentration. So that, so at any particular point, so upon the exponential curve or circular, so at one point, what is the that time value on x-axis, concentration, y-axis? How we can identify means we are writing one tangent. So according to mathematics, so direct you can take this smallest r value, next here time t value. So here instantaneous rate equal to, that is dx by dt. So that equal to direct r value divided by that time. At particular time, how much concentration is there? So directly you take that one. So that is instantaneous. It is nothing but slope also. The slope is nothing but instantaneous rate. Here also the slope is average rate. So this is mathematical application type. The reaction rate must be, the reaction rate must be taken for 1 mole of substance. So this is very important. See, suppose in a chemical reaction we have so many number of moles in either reactant or product. How that value you must take as a constant means every concentration you must take for 1 mole of substance. Then only it is you can compare with others easily. See, suppose you take AA. Small a moles of A is react with small b moles of capital B. Then it become as small c moles of capital C and small d moles of capital D as a products. So then the reaction rate that is R. Otherwise dx by dt. So that equal to, say here the A is with how many moles? Small a moles. If for 1 mole means you take minus 1 by A dA by dt. It is rate. So why you are taken minus means reactant is decreases. For A moles it is. For 1 mole 1 by A. So this is equal to minus 1 by B dB by dt. So it is reactant, so write minus B moles. For 1 mole means 1 by B. Next this is equal to, so plus 1 by C dC by dt. Next that equal to plus 1 by D dd by dt. So in the 4 options, any one you take, that is the reaction rate only that explains. So compulsory, very important, whatever the reaction number of moles are present, you must taken for compulsory 1 mole of substance only. Next, some more examples we will see. See, suppose formation of ammonia. You can take N2 plus 3H2 gives rise what? 2NH3. So what is the reaction rate means? Minus d of n2 by dt equal to minus 1 by 3 d of h2 by dt. Because of 3 moles you take 1 by 3, 2 moles, so that is a product, so plus 1 by 2 d of nh3 by dt. So in examination how they will ask, see, the decomposition of hydrogen rate equal to x. What is the formation of ammonia? They can ask. This value is equal to this value. This value equal to 2, you take this time. So 2 by 3x is your answer. So like that they will ask direct questions from this. Suppose you take H2 plus I2. H2 plus I2 gives rise to Hi. So how you can write reaction rate? R equal to minus d of H2 by dt equal to minus d of I2 by dt. So that equal to plus 1 by 2 d of Hi by dt. Next, suppose PCl5 is decomposed. So you are getting PCl3 plus Cl2. So what is the rate? Reaction rate equal to minus d of PCl5 by dt equal to plus d of PCl3 by dt, that equal to plus d of Cl2 by dt. So different examples you are taken means they will ask in different manner. Suppose you take N2O5, 2 moles of N2O5, we are heated. So you are getting 4 moles of NO2 plus O2. So here what happens, reaction rate minus 1 by 2 d of N2O5 by dt. So this is a decomposition, this is a formation. So this is a plus 1 by 4 d of NO2 by dt equal to plus d of O2 by dt. See, in examination what they will give, the formation of NO2 is X. What is the decomposition of N2O5? They will ask. You want this value means 2, you take this side. So 2 by 4. So X value they given. So 2 you take this side. 2 by 4 X means X by 2 is your answer. In direct in these three combinations, any one they will provide. They will ask third one or any one. So direct problems you can solve that one. So next concept, the factors, the factors affecting, the factors affecting on reaction rate. So you remember as so Natkati Sali. See what are that one by one you write nature of reactants or products. Next, second, temperature. Third one, concentration of reactants. Next, fourth, catalytic effect. So catalytic nature. Next, surface area. Next, sixth one, light. So presence of light energy. See. So how to remember? Just Natakati Sali. So that is over. See, nature of reactants and products. So here, ionic reactions. Ionic reactions are fastly takes place. Next, covalent reactions are slowly takes place. So that is the nature of reactants and products. Suppose the reaction is favored in polar nature, means you must take polar solvent. Suppose the reaction is favorable in non-polar, means you take compulsory non-polar solvent. So according to that you can increase the rate, otherwise decrease the rate. Next, temperature. So temperature, each 10 degrees centigrade, otherwise 10 K value, the reaction rate become as a double. Rate equal to double. Double or triple, majoritarily it is a double. Suppose in mathematical formula, if you want to write means that is rate of T2 temperature divided by rate of T1 temperature equal to temperature coefficient to the power of T2 minus T1 by 10. So means in what way it is useful means, suppose starting, so suppose the rate, suppose concentration, reactant concentration is there. So it is increasing the temperature. So starting it is 30 degrees centigrade. 30 degrees centigrade the reactant rate is something is there. So at 60 degrees centigrade, so what happens to the rate? They will ask a question like that. At 30 degrees centigrade, the rate of the reaction is R. At 60 degrees centigrade, what is the rate? So 30 to 40, it become as double. 40 to 50, double. Next, 50 to 60, double. So that means how much? So the mu value is 2. So the rate. So rate 2 by rate 1 equal to. So that is a double. 2 to the power of. So how much temperature? 60. 60 minus 30. That is 30 by 3 by 10. So 30 by 10. So that is 2 to the power of 3. So that means what? 2 to the 4, 4 to the 8. So 8 times the reaction rate is increases. So like that they will ask questions. See that. So here we are completed nature of reactants and temperature. Next, third. See, concentration of reactants. So concentration of reactants we are increasing means it is directly proportional to reaction rate. So because of what happens, you are increasing the concentration. Starting 50 molecules are there, you are taken 100 molecules. Then what happens? Number of reactants are collision with each other. After bombardment, more amount of reactant is converted into product. That means reaction rate is increases. Next, catalytic effect. Next, catalytic effect means here we have two catalysts are there. So positive catalyst. So positive catalyst and negative catalyst. So positive catalyst is doing what? Activation energy, it is decreasing the activation energy and the reaction rate is increases. So positive catalyst is doing what? The reaction activation energy is decreases, more number of reactants converts into product, means reaction rate is increases. Negative catalyst increases the activation energy and decreases the reaction rate. So whatever you want to speed up the reaction means you take positive catalyst. You want to decrease the speed of the reaction, you take negative catalyst. So that is important. Next, surface area. Next, the surface area is also directly proportion to reaction rate. So the best example you want to take means you take NaCl crystal. NaCl crystal you take into the water. Next, NaCl you take powder. NaCl powder you are taken into water, which is fastly dissolves. So NaCl crystal, it is slowly dissolves. We can observe. Suppose NaCl powder you add, so it is fastly dissolved. So that means what? Here, surface area, crystal means surface area is less. Powder means surface area is more. So the powder compared to the solid, powder has more surface area. Surface area increases, that is fastly dissolves. Surface area less means that is slowly dissolves. So the reaction slowly or moving or fastly, it is depending on surface area also, and it is directly proportion to that. Next, light energy. Suppose some reactions in the dark, they are not takes place, otherwise slowly takes place. So in the presence of light only that reactions are fastly takes place. So the best example, you take hydrogen react with chlorine in the presence of dark, so you are getting 2HCl, but this process is what? Very slow. Suppose hydrogen react with chlorine in the presence of sunlight. So it is a vigorous reaction. So very fastly takes place. So means the energy has a suitable frequency to break the bonds. So then the reaction is fastly takes place.